This is Chapter 2, the chemical level of organization for anatomy and physiology. The study of chemistry is essential in learning anatomy and physiology because chemicals make up the basis of all living things. Chemistry is the science that deals with the structure of matter, and matter is anything that takes up space and has mass. It can either be living or non-living, and we all understand, hopefully, that we are living things, but non-living things play an important role in our lives. They are the building blocks of living organisms, including the human organism. Chemical characteristics determine physiology at the molecular and cellular level. Chemicals make up our structures determine the function of our bodies. And in that way, anatomy, the study of structure, and physiology, the study of function, come together. Matter has three primary states: solid, which is of constant volume and shape; liquid, which is constant volume but the shape can change; and the gaseous state, where both volume and shape can change. And if you think of water for a minute, I'm sure you all know that the solid water is ice. Liquid water is that, what you might have in a glass sitting beside you right now if you're thirsty. And then there is also water vapor, which is found in the gaseous state in the air that you breathe. Module A1 starts with Objective 1, which is to understand the structure of an atom, knowing the location and charges of each subatomic particle. And you can find that in Martini and Knapp, pages 29 through 30. The atom is the smallest stable unit of matter. There are three subatomic particles that we're interested in when we're dealing with anatomy and physiology. The proton, which you find here in the center, which is called the nucleus. The neutrons you also find here in the center of the atom. And the electron, which is found here orbiting the nucleus. There are other subatomic particles, but we're just going to focus on these three because they make the most sense in understanding how chemicals act and react and how we perceive those chemicals. The proton is, again, labeled P here in the center of the atom. It has a positive charge, hence the plus sign. It has mass, which it means it is a more weighty, it takes up some space, and it also is located again in that nucleus or that central region. Along with the neutrons, the second type, the neutron has a neutral charge or no charge. It has also notable mass. It's about the same size as the proton and is also located in the nucleus. And then the last subatomic particle is the electron. And the electron is going to be found in an area what some people call an electron cloud, or you also hear people talk about shells and orbitals, but they are moving around the periphery outside of the nucleus. They have very little mass, they are constantly in motion, and their charge is negative. Again, the nucleus is the central region of the atom and is the location of the protons and the neutrons. There are a couple of different things that you need to understand about atomic structure. One is the atomic number, and the atomic number equals the number of protons that you find in the nucleus of a particular atom. That number is unique to an atom. If you change the number of protons, you change the actual atom that you're dealing with. And we'll talk in a little while about elements, and elements are very unique structures in the chemical world, and each element has a specific atomic number. Over here on the right hand side you see helium, and helium has 2 protons in its nucleus, and its atomic number is 2, and no other element is going to have 2 protons in the nucleus. Only helium has 2 protons. Atomic mass is another thing that we need to understand about atomic structure, and that also you may hear it called atomic weight, but atomic mass is a little more specific because mass is basically how large something is. We think of it in terms of weight. Weight changes depending on gravitational pull. So if you're on the moon, your weight may be less than if you're on Earth, but your mass doesn't change unless you went on a weight loss program on the way to the moon. But protons and neutrons together make up atomic mass. So the atomic mass of helium is going to be 4 because it has 2 protons and 2 neutrons. The electron cloud is the largest area of the atom. It takes up the most space in the atom. It is the location of the electrons, and it's the electrons that are going to determine how an atom acts and reacts with other atoms. Another term that you'll hear used when talking about the electrons are electron shells. And electron shells represent energy levels. At the lowest energy level is the shell that's closest to the nucleus. And as you go farther away from the nucleus in the electron shells, you gain more and more energy, and they become less and less stable as you get farther away from the nucleus. So the closer the electrons are to the nucleus, the more stable those electrons are and the less reactive they'll be. So they have a less of a tendency to be involved in chemical reactions. Now here are 4 different atoms represented by A, hydrogen, and these you can also find in your textbook. So A is hydrogen. Hydrogen has 1 proton in the nucleus, and that proton is balanced by 1 electron. So overall, hydrogen has a neutral charge. It has no neutrons in the nucleus and in this state, so its atomic mass and its atomic number in this particular atom of hydrogen is going to be 1. Here's helium, which we saw before, and in helium you also have 1 proton and another proton, so that makes 2 protons, and that would be a charge of 2 and then a positive charge of 2, and then you have 2 electrons, a negative charge on 1 electron, negative charge on the other. So the 2 negative charges are going to balance the 2 positive charges of helium. Lithium is another example. Again, 3 protons. This is showing 4 neutrons, and so that's going to be a little bit different because lithium in this state here is going to have an atomic mass of 7 because it has 4 neutrons and 3 protons, so that's a total of 7 mass units. Notice that the first shell of electrons has 2 electrons. The second shell in the case of lithium is going to have 1. The arrangement of the shells is going to vary. The very first shell, and these shells are called valence shells, that first shell is going to have a maximum of 2 electrons. The second shell is going to have a maximum of 8 electrons. So when the outer shell is full, as long as it's not just the first shell, if it has more than one shell and the outer shell is full, you will have 8 electrons in that outer shell. Now there's some variation which you'll learn about later on when you take chemistry, but for our purposes we're going to stick with 8 as the number for a full outer shell of electrons. So you can see here that helium has a full outer shell with 2 electrons because it's a single valence shell, and then the neon has 8 electrons and is full. Helium and neon have a tendency to not be reactive because they have full outer shells, and it's along these outer shell electrons that chemicals are going to react with other chemicals, where atoms are going to react with other atoms. So hydrogen, having a half empty or half full, I guess you could say, outer shell, is going to have a tendency to react, and lithium is also going to have a tendency to react because it's got that single electron in its outer shell. So outer shell electrons interact with other atoms and can form molecules and compounds. Atoms with full outer shells are non-reactive, hence we have the helium and the neon that we saw on the previous slide. Let me back up again to this slide.